All right, so we've got our DH parameters all listed out in this table here. We've got for link 2 and 3. And we noticed that we kind of had a little bit of a kerfuffle remembering what the difference is between Ri and Di and the difference between alpha I and theta I. So that's just something that you just want to kind of have the definitions handy and be able to work your way through those. And now it's time for us to build our homogeneous transformation matrices. That's a mouthful. HTMs, right? So let's look at A1 first. So A1. And something to remember is that our alphas aren't variables. And our RIs are never variables either. And the reason RIs are never variable is because we intentionally place our z-axis such that our d is always going to be our variable. That's just the way it works by the way we assign our axes. So if you ever end up with a case where your r is a variable or your alpha is a variable, that means that something may have gotten screwed up, and it likely didn't apply your axes following the right rules. Anyway, so remember we've got our standard form for how we make these matrices, and that's just the big 4x4 guy here. Let's and so the first thing is the cosine of theta I. So in this case, we've got a theta 1. So we're just going to have cosine theta 1. And then we've got the negative sine theta 1 times cosine alpha 1, in which case cosine of 0 is a 1. That means we're just left with negative sine theta 1. And then we have this term here is the sine of theta 1 times the sine of alpha 1. So the sine of 0 is a 0. This whole term goes to 0. And then we've got Ri times the cosine of theta I. Ri is a 0, so that means this term goes to 0. Now I've got the sine of theta 1. So we can just put sine theta 1. And here we've got the cosine of theta 1 times the cosine of alpha 1. In which case we've got a negative 90. So that comes out to be a 1. So what we end up with here is a cosine of theta. Oops, sorry, that's supposed to be cosine theta 1. And then what do we have here? We've got negative cosine theta 1. Negative cosine theta 1. So theta 1, negative cosine, and then the sine of alpha 1. That is also going to bring us to a 0. This is using Ri again, which is a 0, so that means that term goes to 0. This guy here is always a 0. Then our sine of alpha 1, so our sine of negative 90, this comes out to be 0. And then we've got cosine of alpha 1, out to be a 1. And we've got or this guy is just d1. d1, and we've always got this 0, 0, 0, 1. We've always got that there. All right, now alpha 2. So alpha 2, let's look at alpha 2 here. The good thing is we've got a lot of sines and cosines, and oh shoot, I was I was explaining here as if our alpha I was -90, but it's actually 0, and so that's I was saying the right things because I was looking at my notes, but I was doing some fake math. This is right. It'd actually be this. Make sure we're looking at alpha 1 equals 0. Uh, this next guy here, we've got fixed angles, and so that means we can actually just compute what a lot of these guys come out to be, and it should just be a lot of zeros and ones. So we've got the cosine of theta 2, this is our HMT for number 2, the cosine of theta 2, cosine of 0, this comes out to be a 1. And so I'm just going to kind of start giving these because it really is just kind of plugging these in there and seeing what we get. We've got a 0, 0, 0, 0, 0, 1, 0, 0, -1, 0, D2. We always end with a 0, 0, 0, 1. And let's get our A3 as well. So A3, no surprise, it's going to kind of look similar to this guy. The only thing is we don't have a -90, we get a 0 in there. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, D3, and 0, 0, 0, 1. Always end that way. All right, so we've got our 3 homogeneous transformation matrices. And the last thing is we want to get our final kind of transformation matrix. So figure out where 3 is, 0's coordinate system. And so we do that by taking this kind of expression here, multiplying these guys together. Now, we have to be careful. Matrix multiplication is not commutative. So what we have to do is you kind of want to think of it collapsing on itself backwards from 3 to 2 to 1 to 0. That means we need to multiply these guys, then take this and multiply it for times A1. We just kind of want to collapse it back. Do the furthest joint, the next furthest joint, so on and so forth, and keep heading back. And so I'm not gonna go over it, right? Just our final answer here. We've got the cosine of theta 1, 0. This should be negative sine theta 1 and negative sine theta 1 times d3 sine theta 1 0 cosine theta 1, got a cosine theta 1 times 3 0 1 0. This turns out to be d1 plus 2. We're always going to end with 0 0 0. Once again, we've got 2 matrices kind of built in here. Right, remember this is our rotation matrix, and this is our translation matrix. Oops, kind of floppy there. Transformation matrix. So this is really what's telling us where 0.3 is relative to this coordinate system right there. Um, and since we don't have any offset off of this, we don't really need to use a rotation matrix. This is really kind of our end thing to tell us where our x, y, and z is at. All right, well, that's certainly a mouthful.